Hello everyone. I welcome you all to my class. As a part of series of open channel flow, today in this video we are going to learn about the difference between open channel flow and pipe flow, total energy line and total head, and the different types of forces that are acting on the fluid. The difference between open channel flow and pipe flow. Open channel flow. Pipe flow. Open channel flow must have free surface. This free surface is subjected to atmospheric pressure, and the flow takes place under gravitational force. No external pressure is required for the flow to take place in open channel flow, since gravitational force is the governing force in open channel flow, so the analysis is done using Froude's number. No free surface is available in pipe flow. This is because of pipe flow, in which the pipe flows with full discharge under hydraulic pressure. That indicates the flow in pipe takes place due to the pressure difference. In the pipe flow, the analysis is done by Reynolds number. In open channel flow, the depth of flow, discharge, slope of channel at bottom, and at the free surface are interdependent. In pipe flow, there is no dependency in between these parameters. The cross-section may be of any form. Example, rectangular, triangular, compound, or in case of natural stream it is irregular along the flow direction. The cross-section of pipe is generally kept to be circular. The relative roughness changes with level of free surface in open channel flow. The relative roughness is a fixed quantity in pipe flow. Flow area is determined by geometry of channel, plus the level of free surface, which is likely to be changed along with flow direction, and with time as well. In pipe flow, flow area is fixed by pipe dimension, and is usually same along the flow direction. In open channel flow, hydraulic gradient line coincide with free water surface, whereas in pipe flow, the hydraulic gradient line is usually above the conduit. Our next topic is total energy and total head. Total energy. It is the summation of datum energy, that is elevation energy, pressure energy, and kinematic energy. Datum energy. Datum energy is the multiplication of mass of fluid, acceleration due to gravity, depth of fluid from datum to the channel bed. Pressure energy. Pressure energy is the multiplication of pressure of a fluid, that is water in our case, and volume of fluid occupied in given volume. Kinetic energy. Kinetic energy is the energy an object has because of its motion. It is the multiplication of half of mass of water in velocity squared. Hence, total energy equals multiplication of mass of fluid and acceleration due to gravity, and depth of fluid from datum to the channel bed, plus the multiplication of pressure of the water by the volume of fluid present in given volume, plus half of mass of fluid and square of velocity of water in the direction of flow. Total head. Total head is defined as energy per unit weight of water. Total head is equal to the summation of datum head, pressure head, and kinetic head. The sum of datum head and pressure head is known as hydraulic head. Let us consider a horizontal channel, or a conduit with a free surface at the top, in which flow takes place, and is located at a height of z from the datum, that is datum head, and the flow takes place in the channel or conduit, with free surface at a depth of h, w. The sum of datum head and pressure head h, w is known as hydraulic head or piezometric head h, and let the channel with free surface be flowing with a velocity v, such that the kinetic head is located a height of half of square of velocity to the acceleration due to gravity. Hydraulic gradient, denoted by the letter I. Hydraulic gradient is the ratio of hydraulic head loss to the length of flow. Line, slope of which indicates hydraulic gradient is termed as hydraulic gradient line. Line, slope of which indicates energy gradient is termed as total energy line or energy gradient line. Let us consider a channel which is flowing with a velocity v, has a bottom slope of theta, which is located at a height from the datum. Let us consider a section in an open channel flow, that is a channel which is flowing with a free surfaces at a height of z1 and z2 from datum, and depth of flow in the pressure head in the considered section v, y1 and y2. The line joining various points of pressure head is known as hydraulic gradient line, which coincides with the free surface in open channel flow. Since the flow in the considered section is varying, locate the kinetic head from the top of free surface of open channel flow, and the line formed due to joining of various points of kinetic head is known as total energy line or energy gradient line. Now, let us consider a section in a pipe flow, that is a conduit, in which free surface is not available. That means pipe is flowing with full discharge, at a height of z1 and z2 from datum, and depth of flow in the pressure head in the considered section v, v1 by y, and v2 by y from the line joining the center of the pipe flow. The line joining various points of pressure head is known as hydraulic gradient line, which is above the surface of the conduit in pipe flow. Locate the kinetic head and draw a line joining the kinetic head. The line formed due to joining of various points of kinetic head is known as total energy line or energy gradient line. Velocity distribution in case of open channel flow is logarithmic or power law distribution, whereas the velocity distribution in pipe flow is parabolic for laminar flow. We became familiar that in open channel flow the velocity distribution is logarithmic or power law distribution. But the maximum velocity will takes place at the below layer and becomes minimum at the bottom layers in open channel flow. That can be observed in the diagram shown on the screen. In pipe flow, the velocity distribution in pipe flow is parabolic for laminar flow. But the maximum velocity will takes place at the mid-layer and becomes minimum at the contact layers to the surface in pipe flow. That can be observed in the diagram shown on the screen. Our next topic is the different types of forces that are acting on the fluid. The different types of forces that are acting on the fluid are inertia force, gravity force, viscous force. Firstly, we deal with inertia force. Inertia force, it is a common property to all the bodies that remains in their state either rest or in motion, unless some external cause is introduced to make them alter their state. Next, gravity force, it is the force due to own weight of body. It is the product of mass and acceleration due to gravity. Viscous force. This force is due to resistance of fluid against deformation which develops between different layers of fluid. By using the concept of forces, we move into next topic, that is all about Reynolds number and Froude's number. Reynolds number. It is a dimensionless number that signifies the dominance of inertial force over viscous force. RE equals rho VL by mu. From above equation we can clearly understand that Reynolds number is dependent on viscosity, but not on gravitational force. Hence, we can conclude that Reynolds number can be used in pipe flow, where viscosity between layers of fluid plays major role. Froude's number. It is a dimensionless number that signifies the dominance of inertial force over the gravitational forces. Froude's number is equals to the square root of inertia force divided by gravitational force, which is equal to V by under root of GL. Since in open channel flow the flow takes place due to gravitational force place, so the analysis of open channel flow is done by the Froude's number.